Hello, today we're going to be talking about solutions and mixtures. So what is a solution? A solution is another name for a homogeneous mixture or homogeneous mixture. And that means it has a uniform composition throughout. Typically, when we're talking about solutions in chemistry, we're talking about liquids. And frequently it's an aqueous solution, which means it's dissolved in water. But you can also have solutions that are gaseous or solid. It's just not common usage for us to call those solutions at that point. A couple of things that you should know about solutions. Because it's completely homogeneous, you cannot filter them to separate the components. Filtering does not work. Filtering only works when you have like a solid in a liquid, so that way you can get the thing with the larger particles on top of the filter, and whatever's dissolved actually into the solution passes through the filter. Let's see. So you could separate the components of a solution using something like chromatography, which separates based on intermolecular forces, or you could use something like distillation, which separates based on different boiling points. But filtration will not work. Now, solvation is what we call it when a compound is dissolved by a solvent. The substance being dissolved is called the solute. The substance doing the dissolving is called the solvent, and altogether it forms a solution. Now, this picture is an example of an ionic compound being dissolved by water. It's sodium chloride. So water molecules are polar, and the hydrogens have a slightly positive charge, and the oxygens have a slightly negative charge. So the negative oxygen side is attracted to a positive sodium ion, and it surrounds it. Whereas with the chlorine, because it's negatively charged, it's surrounded by the positive hydrogen partial charges there. Now, you can be asked to draw this on the AP exam, so just kind of get used to it. Sometimes they'll have you draw just one water molecule or multiple water molecules. And the attraction is what we call an ion dipole force. Ion dipole. Now, the same thing happens if you don't have an ionic compound. It just won't necessarily orient itself as specifically. As long as, if you have like a polar compound dissolving in water, you'll the negative end of the polar molecule will be attracted to the hydrogen end of the water, and vice versa. Or if you have, things that are non-polar, can form line of dispersion forces with other things that are non-polar to dissolve as well. And we'll get a little bit more specific with what helps things dissolve and what doesn't help things dissolve. But for now, it's probably just useful for you to know that polar and ionic compounds will typically dissolve in water or other polar solvents. Non-polar substances tend to dissolve in other non-polar substances. Okay, our most common formula that we use for concentration in chemistry is molarity. And molarity, we use a capital M for molarity, and the equation is moles of solute per liter of solution. So this is the total solution altogether, not just the solvent. Now, because it's based off of the volume, the liters, that means molarity is temperature dependent. Temperature dependent. So in certain situations, it does not make sense to use molarity as the unit because, like if you're changing the temperature, the molarity will also change, so it's not the most useful. But for the most part, for this class anyway, you're going to be keeping things at a constant temperature, so we can use molarity. And molarity is moles, again, per liter. So you need to make sure that if they're giving milliliters, that you convert that into liters. You should also know that for molarity, we'll typically use the brackets. So let's say I want to know the molarity of sodium chloride. You can use brackets just to indicate, okay, I want the concentration of sodium chloride is, whatever molarity. Otherwise, you'll use the significant digits, the same as any other problem.
So when you dilute something, you're adding water to it. But the moles of your solute stay the same. Now from there we can take that molarity equation, which is moles per liter, and if you rearrange that, liters times molarity gives you moles. If I replace V for volume, value times molarity will give you moles. Now, when you're adding water, the volume changes, but the moles stay the same. So from here, we can get M1V1 equals M2V2. And so this would indicate your molarity and your volume before dilution, and then your molarity and volume after dilution. And again, it's because the moles stay the same, we can track how the molarity changes when the volume changes. Okay, we can also find concentration for ions as well as whole compounds. It's going to be dependent on the specific ionic compound that you're looking at. So let's say I have a 1 molar sodium chloride solution. Now, sodium chloride is ionic, it dissolves in water. It dissociates in water. That means it breaks down into its ions, sodium ions, and chloride ions. Now, because sodium chloride has a 1-to-1 relationship, every time one sodium chloride formula unit breaks down, it forms 1 sodium ion and 1 chlorine ion. So because of that ratio, it will be 1 molar in terms of sodium ions and 1 molar in terms of chlorine ions. But if you have something that doesn't have a 1-to-1 ratio, so let's look at, I have 1 molar calcium chloride. When that dissolves, every formula unit of calcium chloride will produce 1 calcium ion, and it will make 2 chloride ions. So that means the solution will be 1 molar calcium, but it will be 2 molar in terms of chloride, because it has twice as many chlorine ions as it does calcium ions. So if you think about it in terms of particles, every time you have 1 mole of sodium chloride, and when it dissolves, it will form 1 mole of sodium ions and 1 mole of chlorine ions. If you have 1 mole of calcium chloride and that dissolves, you will get 1 mole of calcium ions and 2 moles of chlorine ions. So you need to take the mole ratio into account when you're looking at concentration, just like you would with moles. So let's talk just briefly about how you need to make solutions or dilutions. So if you're making a solution with a solid, the first thing you want to do is weigh the proper amount of the solid out. So you need to know the grams of the solid that you need. You weigh that out on a balance. The next thing you want to do is you want to transfer that solid into a volumetric flask. Now, volumetric flasks are the ones that have a really long neck and a little kind of bell on the bottom, and it has just one line. And so volumetric means it's very, very specific for that one volume. It's very accurate for that one volume. So you want to make sure that the amount of solution that you need is the same as the amount that the volumetric flask measures. So like if you want 50 milliliters of your solution, make sure you have a 50 milliliter volumetric flask. So you'll transfer the solid into the volumetric flask. And then if you're using like a weigh boat or a weigh paper, you can always rinse that with water to make sure you get every little bit of solid into the flask. And then you will slowly add DI water. You always use deionized water or distilled water while stirring. Because the solid could change volume just a little bit while it dissolves, you want to make sure that you're stirring as you're adding the deionized water, or like swirling, and then you will add DI water all the way up until it is exactly at that line. So the bottom of the meniscus touches the little measurement of the line on that volumetric flask. And if you go past that line, you can't go back. So it's not like you can take out just water molecules. Some of the solid will have dissolved, so you have like one shot at it. So that's if you're making a solution from a solid. The other thing would be making a dilution. Okay, so you're changing the concentration of a solution that you already have. Dilutions will typically use the dilution equation, so M1V1 equals M2V2. But once you figure out how much you need, okay, you're going to measure the stock, and you will typically add that into your volumetric flask. Again, we're going to use volumetric to make solutions because it's very accurate for that one volume. So you're going to measure the amount of stock that you need and put that into your volumetric flask. There's a couple different ways that you could measure the stock, and I will kind of talk about their accuracy. So you could use a graduated cylinder. Graduated cylinders have lots of lines on them. That's why it's called a graduated cylinder, but it might not be as accurate as other methods, but that's a graduated cylinder is one way. You can use a burette. Burettes are almost exactly like graduated cylinders, except they're kind of upside down. They have a little stopcock, so you can open and close and deliver from the bottom, like this. Or you could use a volumetric pipette. And so a volumetric pipette is very similar to the pipettes we use in class. However, it measures an exact volume. Right? Volumetric means it measures an exact volume. So if you have a volumetric pipette in your list of supplies, you want to make sure you choose that one because that one's going to be the most accurate. So let's say you need 25 milliliters of the stock solution. You'll use your 25 milliliter volumetric pipette to transfer that into your volumetric flask. And then you will add DI water while stirring. The only exception to this is if you're making an acid dilution. So if you're making a acid solution, you want to make sure you have some water first in the flask and then add in the acid. That's because when the acid is dissolving in water, it's a very exothermic reaction, and so if you just put a little bit of the water in with it, it can release a lot of heat very quickly and be very dangerous for you. So you always put acid into water. So have a little bit of water at the bottom, add in the amount of acid you need, and then continue adding water while stirring until it gets to the line. So those are your equipment options. That's how you make solutions and dilutions.
Okay, let's take a second and talk about saturated solutions, unsaturated solutions, and supersaturated solutions. So there is a limit to how much can dissolve in a particular solvent. If you've ever tried to add too much sugar to your coffee, you'll know that there's a limit to how much can dissolve because you'll notice some sinking to the bottom. So if you have the exact perfect amount of solid that can dissolve in that solvent, then that's called a saturated solution. Saturated. That means you cannot dissolve any more of that particular solute. It is exactly full of solute in that particular solution. If you have less than the full amount, that's called an unsaturated solution. Most of the solutions that we're going to deal with will be unsaturated. But let's say the biggest thing that you need to know with this is that if you have your solvent, which is typically water, but it doesn't have to be, and you are adding your solute in, and you're stirring, you're mixing it as you go, but eventually if you start seeing some of that solute at the bottom, that means that the solution is saturated because you're noticing that there's some solid left over at the bottom. Okay, so the actual solution part is a saturated solution. There's excess solid at the bottom that you could filter out. But anytime before that, it would be considered unsaturated. Supersaturated is something completely different. Only certain compounds will form a supersaturated solution, and it is somewhat rare. So a supersaturated solution is where you heat up a solvent so it can dissolve more of your solute. And then if you slowly cool it back down, sometimes those particles will remain suspended. So you'll have a lot more particles than could normally dissolve. That's supersaturated. But if you agitate the solution in any way, as long as you do something to it, basically, you can get all of the excess will precipitate out immediately. And this is actually a really cool phenomenon, but if you have certain types of hand warmers, we'll have like a clicky thing inside of it, like a metal tab thing that if you click, it will suddenly solidify. And it's because of a supersaturated solution. And that precipitation, if it happens very quickly, it can release a lot of heat, depending on the substance. But that's how those hand warmers work. You have a supersaturated solution, agitate it, get the solid to precipitate out, and that solidification releases heat. So supersaturated solutions are rare and they don't come out very often, but you definitely need to know the difference between saturated and unsaturated. Okay, let's do a couple examples with molarity calculations. Calculate the volume of a 1.25 molar lithium chloride solution that can be made with 13.3 grams of lithium chloride. You need the molar mass of lithium chloride. Anytime you see grams, you should convert grams to moles using the molar mass. Let's see, lithium is just about 7, chlorine is 35.5, so that's 42.5 grams per mole of lithium chloride. And you get 0.313 moles of that lithium chloride. Then molarity is equal to moles over liters. So you can do the 1.25 molar, the 0.313 moles, and solve for the liters. And when you do solve for liters, you get 0.251 liters. Now that is 251 milliliters if you move the decimal back over. But you could, since the question did not specify, you can just leave it in liters if you'd prefer. Okay, so for this example, we're going to find the concentration of chloride ion by dissolving 10 grams of zinc chloride in a solution with a final volume of 500 milliliters. Remember, whenever you see grams, it's a good bet you're going to have to change it to moles using the molar mass. So if you add up zinc and chlorine, you get 136.5. So grams per mole. And when you solve for that, you'll get 0.0733, and that's moles of zinc chloride. But I want to go ahead and, because there's 2 chlorines, so there's, for every 1 zinc chloride, there are 2 chlorine ions. So I need to multiply by 2 to get just the chlorine moles. When I do that, I get 0.147 moles of just chloride ions. There it is. And now that we have the moles of chloride, I can divide by the volume in liters. And remember, brackets means molarity. Molarity is moles per liter. So 500 milliliters, that's 0.5 liters. And so when you go ahead and divide that, you'll get 0.293 molar solution. And that's for your chloride ions. Remember to label your unit and your substance.